All right, so let's review multiplication of fractions. And we have a couple of different ways to go about that. The easiest one to draw as a person is the area with a rectangle or a square. And then we have these other toys that we can use, like the color strips or the pattern blocks. And the point of using anything like those mathematical toys, like again, the color strips, or color rods, or the pattern blocks that we were playing with, or rectangular areas that we were drawing, is we're trying to just justify why we get a certain answer when we use those things. Why? And that why depends on a couple of things in addition to using the toys. Number one, it depends on what the operation means. Like, what does multiplication mean? And so I could say multiplication means an area. So then I'm thinking about that model over there. But that model also carries over to pattern blocks, for example. Area. And two, I have to think of what a fraction means, and that's a part of a whole. And the point of all of these pictures and saying, hey, this is what these things mean is to demonstrate why. And so I'm trying to emphasize this right now because you're about to take a test on this stuff. And what we're doing here is we're modeling the idea of a fraction. To model that idea, we need to do two things. We need to illustrate what's going on, reality, and explain that illustration. And so the activities have been guiding us through these things. I've been trying to do examples in class, so we're going to do another one here. In order to do the examples I want to do, I'm going to put a little more randomization in this today. I'd like you each to randomly pick a number between 1 and 20 and type it into the chat right now. So I need some numbers, inspiration from you guys. So give me some numbers between 1 and 20. Awesomeness, look at those. Okay, does everyone give me a number? Not yet, keep going. If anybody wants to throw in 2 numbers there, give me another one. Okay, not everyone's participating. Come on, give me some numbers here. Type into the chat, give me a number. There we go. Nice. Okay, so I got a bunch of numbers there. So I'm gonna, do I really want to pick any of those to do this? Maybe I'm gonna ask for more than I wanted. How about, you guys are making my life way harder than I wanted. What was I thinking when I asked for this? That's okay. Ah, thanks, Amy. That helps. All right, let's do 5, oh, that's supposed to be a 5, halves times 7/3. So I'm going to draw this in a couple of different ways. So my model for this to illustrate is I'm going to use multiplication as an area. So that's going to be a base and a height. And then a fraction is an equal part of a whole. And so ultimately, when we talk about fractions, we need to know what is a whole so we know what the parts of a whole are. 2 ways to view this. I could view it as 5 halves times 7/3, or right, we can convert. 2 goes into 5 twice with 1 left over. So that'd be 2.5 times 3 goes into 7 twice with 1 left over. So that would be times 2 and 1/3. Do that right? Looks like it. Yep. So I'm going to consider both of these as I draw this out. And let's see, they're about the same. So yeah, that's okay. So I'm going to set myself up a grid for my area. And then on this grid, I'm going to have to mark off wholes and halves. So I need to get to 2.5. So maybe I'll do something like 1, 2, 3. It's not too bad. And if that's 1, that would be 1, 2, 3. So for my illustration, I want to show an area of 5 halves by 7/3, and I'll let this be the base, and I'll let this be the height. So that's 1, 2, 3, 1, 2, 3. And then, let's see, for my base, I need halves, so I should mark off some halves here. And I want 1, 2, 3, 4, right here would be 5 halves. So that's the edge of my figure for the width, the base. And then height needs to be measured in thirds. So thirds, thirds, thirds. And I want 7 of them. So 1, 2, 3, 4, 5, 6, 7. So right there is my 7th third. So then here is my area. Cross that way. Pen's freaking out again. Just charged it. It should behave better. To about there. And then up from there. So that's my answer right there. I'm done. Here's my answer. Okay, what the heck does that mean? So to figure out what that means, what I usually do is I break off the holes. So let's make some lines for the holes. Actually, I should maybe shade the whole thing. So this is my area. But what is the answer? So 1 hole is across that way, 2 holes is across that way, 1 hole is that way, and 2 holes is right there. So I see a whole bunch of holes here. There's 1 there, 2 there, 3 there, 4 there, plus this extra stuff. And for the extra stuff, I'm gonna split into halves and thirds. So let's draw my half as the dotted line coming up. Another half, and then thirds. Let's draw those in. It's not the best artistic rendering today. All right, so those are all my thirds. So something to note here, a hole has 6 pieces at the moment. So I'm just gonna make a note of that. 1 hole, and again, what is a hole? A hole is 1 by 1. 1 times 1 is 1, so that right there is 1 hole. 1 hole has 6 pieces. So one way I could calculate my answer is to find out how many pieces there are altogether. Well, there's 7 pieces vertically, right? And there's 5 heading horizontally. 5 times 7 is, on a good day, 35. So as far as my area, one answer could be there's 35 pieces there and there are 6 pieces in a hole. So there's one version of the answer. The other version of the answer is start looking for holes. And so I'm gonna use a different shading for that. Let's use red. There's 1 hole here and there's another hole here. So that's 2, 3, 4, and then a hole has 6 pieces. So 1, 2, 3, 4, 5, 6. Here's another hole there. What do we get up here? 1, 2, 3, 4, 5 pieces. So another thing I can count is counting holes. There are 1, 2, 3, 4, 5 holes. And then there's 1, 2, 3, 4, 5 out of 6 pieces left over. So I could also say the answer is 5 and 5, 6 by looking at that area. So this is pretty similar to the way we worked with whole numbers when we were doing it with base 10 blocks, but we don't have base 10 blocks. Bottom line is we draw out our base, we draw a height, and that forms a rectangle. In that rectangle, we mark off our holes and our fractional pieces, because we're going to have fractional pieces most of the time, so we need to know how many pieces makes a whole. From there, we can get an improper fraction by just counting how many pieces are in the whole grid, and that's just a simple multiplication. 5 times 7 is 35. And each hole is made up of a 2 by 3 grid. And so there's my 2 times 3 in the denominator. And so we get a pretty quick answer in terms of improper fractions. And that process works also with proper fractions. There were a couple of homework examples on that that I'll bring up in a moment. Again, if we wanted to justify in mixed number version, then that means we have to start counting holes, which is akin to dividing by 6, right? If you divide by 6, you're asking how many groups of 6 are there? And when I was doing that, I found there was 1 group of 6, 2 groups of 6, 3 groups of 6, 4 groups of 6, 5 groups of 6 with 5 left over. And that's what this says right here. Questions on multiplication. So this whole thing is, why does 5 halves times 7 thirds equal 35/6? And the answer isn't because you multiply the numerators and to multiply the denominators. That's an algorithm, it's not a reason. So the reason is multiplication is an area and fractions are a part of the whole, and this is what happens. What do you think? Questions, concerns? Okay, so I'm gonna put up another problem, but this time I'm gonna split you guys into groups in the Jamboard. This time I share the Jamboard, so one of the group members is gonna need to somehow put your work in there, which is always the interesting part. And maybe you could collaborate because anyone can edit this at once. So the next problem we're gonna take a look at, something similar. How about 4 thirds, oops, not plus, times, let's stick with 5 halves again. Actually, let's switch it. 5 halves times 4 thirds. I always like the base to be the bigger number. All right, so the question here is why? Is there an answer? What is the answer? And it's group Jamboard time. We'll come back and find the answer together in the next video.